Sorry, it got interrupted before the phone rang, so I had to stop. Okay, so when we're doing this, we know it forms a rectangle, but we need to kind of prove, well, why does it? So I'm going to use that mid-segment theorem. And the mid-segment theorem states that when you connect the mid-segments, that FG is going to be parallel to AC. So we have FG parallel to AC. And we also have EH being parallel to AC. So I have an EH and an AC. So therefore, FG must be parallel to EH. And you can flip it around on the other side and prove that EF is parallel to HG. So by proving they're parallel, then that gives us that quadrilateral, and it shows that it's a parallelogram. And we can also prove it's a rectangle if it were in a coordinate grid. Some ways to prove quadrilaterals are rhombuses. So let's go through each one. Number one says you can use the definition and show that the quadrilateral is a parallelogram that has 4 congruent sides. It is easier, however, to use the rhombus corollary and simply show that all 4 sides of the quadrilateral are congruent. So either way, you can just say that the 4 sides are congruent, or you can go back and you could show that, use the definition of a quadrilateral to say they're congruent. The second way is to show that the quadrilateral is a parallelogram and that the diagonals are perpendicular, using theorem 611. And another way is to show that the quadrilateral is a parallelogram and that each diagonal bisects a pair of opposite angles. So you're just using those to form arguments about rhombuses. The next thing we're going to look at is, it says to show that KLMN is a rhombus. And I'm going to do that by proving that the sides are congruent to one another. So the way that you do that is, we're going to prove that KL is congruent to MN. So I know that KL has coordinate points. I'm going to find the distance, the length of KL. So the length of KL is the square root, that was a horrible square root, and I'm going to do my 5 minus 3 squared plus my 2 minus negative 2 squared. And so underneath there, what I'm going to get is, I have a 2 here, so that would be 4, and that's going to give me a 4, and that'll give me 16. So I'm going to have the square root of 20 for KL. So let's see what MN is now. So I have MN, and MN is going to be the square root, and it'll be 3 minus 1 squared plus 6 minus 2 squared. And so underneath there, I'm going to have a 2 here, which is a 4, and I'm going to have a 4 here, which is 16, and that'll give me the square root of 20. So I do know those are congruent. Let's prove the others. So I want to do KN, I'm sorry, I didn't mean to write that. I meant to write congruent, not parallel. I want to prove that KN is congruent to LM. So first I'll do Kn, and it doesn't matter the order you do them in. So I do Kn, and that is going to be the square root of 5 minus 3 squared and 2 minus 6 squared. And so what that'll give me is, I'm going to have a 2 here, which is a 4, and then I'm going to have a negative 4 there. So I have a 4 plus 16, so that also gives me a square root of 20. And I'm going to do my LM, and that's going to be the square root of 3 minus 1 squared plus negative 2 minus 2 squared. So once again I get a 2 here, which is 4. And then I get a negative 4, which is also 16. So I get the square root of 20 there. So those are all congruent. So therefore I know that it is a rhombus. The next one, what type of quadrilateral is A, B, C, D? Explain your reasoning. So looking at A, B, C, and D, I do know I have the same angles here. Those are congruent. And these are congruent to one another. And so in order to have that happen, it's going to have these sides congruent to one another as well. So we know it's a trapezoid, and we know it must be an isosceles trapezoid. Just because AD is congruent to BC. Now, looking at the next one. We have the diagonals of quadrilateral ABCD intersect at point N to produce 4 congruent segments. So I have AN, BN, CN, and DN, and they're all congruent. What type of quadrilateral is ABCD? So if you have congruent diagonals, then you need to prove your answer is correct. And the way that I'm going to do that is, I know that if I have congruent diagonals, then it's going to be a rectangle. And you just say congruent diagonals. And that's it for today. Okay, we'll work on it together.